And also 2.3. And like I said, this deals with finding the ranges, okay? So finding domain and range. All right, so this homework, they start out giving us a graph, and they want us to determine a few things from that graph. So I'm going to put up a graph here. So my graph is these sets of points here. So they start out on this number one, part A on number one. They want to know, using this graph, what is f of a -6? So y'all, when they ask you to find something like f of -6, what they want to know is, from this representation, they want to know what y value has an x value of -6. Okay, so they're giving me the x value of -6. They want me to find the y value. So that's what they mean by this terminology here. So what I would do is go to -6 on my number line here. So there's -1, -2, -3, -4, -5, -6. And then since this is the x value of -6, I'm looking for the y value of that point that occurs at that -6. Okay, so if we go to our point and we go straight across, we can see that, well, there's 4 right there, so we must be at 5. So that means f of -6 would equal 5, because that's the y value of that point, okay? All right, next that they want to know. They want to know, what is the domain? Well, y'all remember, the domain is the set of all x values. Oh, y'all, let me check something real quick. Are y'all able to hear me? Are y'all able to hear me at all? Anybody? Okay, so we're good to go now. So let me get back to it then. All right, y'all. So on this one, like I said, we're looking for the domain. So remember, the domain is the set of all x values. So we would go through here and find out all the x values of these points. Okay. Now, they're going to give you the parentheses. We just got to put in our x values. So the first x value for the first point, if I went straight down, would be -6. Then the second point, if I went straight down, that x value was -5. Y'all just going to continue along. So the next point go down is -4. My next point coming down is at -3. Next point coming down is at -2. Let's see, my next point is at -1. And then finally, this last point has an x value of 0. So since that one was on the y-axis, it had a x value of 0. All right, y'all, let me let 2 in real quick. Hey, so y'all, that's the trick on that. Now, for part C on this one. So let me bring the camera down just a little here. So for part C on this one, they want me to find any x values for which f of x equals 3. So this part C is basically the opposite of A. On A, they gave me the function with the x value, and they wanted me to find what the y value was. Here, we don't know the x, but they're telling us they want us to find the x that has a y value of 3. Okay, so for this one, we're going to find the x value that has a y value of 3. Okay, so I'm going to go up here and find 3 on the y-axis. So there's 3. So anything on this line, this horizontal line, would have a y value of 3. And if you notice, I got 2 points. So the first point here, if I go straight down, is sitting at -5. So they would have the x equals. I would put in the -5. And then that second point up here that had a y value of 3, if you come down on it, it occurs at -1. Okay, so that's the difference in this one. This one, they're giving me the x value. I found the y value. This one, they're basically giving us the y value, and we're finding the x's. So since 2 points were on that horizontal line at y value of 3, you have to put them both, okay? And then the last thing they want is the range. So remember, the range is a set of all y values. So once again, they'll give us our parentheses, and we're just going to find all the y values of these points. And usually on the y values, I start from the bottom and go up. On x values, I always start from left and go right. So the bottom point, if you go straight across, has a y value of 2. Now, there's 2 points on this line, but I don't have to write it but once. So these 2 points have a y value of 3. Next, these 2 points had a y value of 4. And it looks like these last 2 points here had a y value of 5. So for your problem number 1, they're going to give you a graph with a bunch of ordered pairs on it. And they're going to ask you these 4 things. Okay? Now, question 2 is going to be really similar, but they're not giving us dots on number 2. They're giving us a actual line graph, okay? So y'all want to switch us to question 2 now. And let me bring this back up for us. So y'all noticed on number 2, I actually got a graph of a line here. Almost looks like our absolute value graph. But they want us to find the same things, basically. So for part A, they want us to find f of 2. So basically, they want me to find the y value when x is 2, okay? So remember, y value when x equals 2. All right, so I'm going to go over here, find 2 on my graph, which is about right here. And I'm going to go straight up. Now, y'all, my graph is a little off, but it should be coming right through here when I try to draw this. So there's 2, so I'm looking for this y value. All right, y'all. So it looks like that's going to be 4, right? 1, 2, 3, 4. So when x equals 2, they'll have the blanks like this. F of 2, that's going to equal 4 since it had a y value of 4 at that point. Here's a different one now. They want the domain. But y'all notice, this line goes forever to the right. This line goes forever to the left. So, since these lines go on forever in either direction, let's see what my chat's saying. Since those lines go forever, look at these X's. As you go into the right, it's covering all those. As you go to the left, it's covering all those. So when a graph goes on forever in both directions, we say that that domain is all real numbers. Okay? All righty. For C on this one, they want any X values for which f of x equals 1. All right, so remember what we're looking for now. We're looking for the x values that have a y value of 1. So find the x values that have a y value of 1. Okay, so once again, the opposite of A. A, they gave you the x, you found the y. For C, they're giving me the y value, we're finding the x's. So we need to go to the graph and find where 1 is on the y-axis. So 1 is right here. So I'm looking across. So if you notice, it's right here intersecting. And if I go down, that looks like that's hitting that right at 1, 2, 3, 4, 5. So the first x would be 5. But then if I come across, this is also intersecting at 1 on the y. And if I go down, that x value would be 7. So at the x values of 5 and 7, I was intersecting the y value on 1, okay? And y'all guess what? The last one they want is the range. Now remember, my range is my y values. So here's my y-axis. Now if you notice, this smallest point right here is on the x-axis. So that means that the smallest point has a y value of 0. And then this is going upwards. So from 0, this graph is going up, all these y values, and it continues going up. So none of the y values are negative on this. So we can't say it's all real numbers because it's not coming down into the negative y values. So for on a graph like this, we would say that the range is y such that, so this bar means such that, and remember the range is the y values, right? So what do we know? We know that y is the variable for the range. But what do we know about this range? The y has to be greater than or equal, because notice it's going upwards, not down, so it's going to be greater than equal to the smallest y value, which was 0. And then we would close our parentheses. Okay, so if this would have went down, then I would have said it was less than whatever that point was, okay? All right, y'all, so that's the first two. Basically, you're just looking at a graph and you're finding the domain, the range, and then the x's for what a y value equals, and then the y values for what the x is equal, okay? So what we'll move on to now is actually finding the domain of a function. And that's going to be the big thing for us here, okay? So we're going to be finding the domain of a function. So y'all, here's the thing. The domain of a function. So the domain must include all x values that produce a real number when substituted into the function. Okay, so if I put this x into the function, I have to be able to evaluate it and get a real number out of it, okay? Now, I'm going to tell you, there's only two types of numbers that are not real numbers, okay? Now, one of them we won't mess with now, but that'll be what we call imaginary numbers. Now, we'll look at imaginary numbers later on in life. But for right now, the only thing we're really worried about are fractions, okay? Because what happens when you try to divide by 0? We get what we call undefined. And y'all, undefined is not a real number. So at this point, we are only worried about with any x values that create an undefined when substituted. All right, y'all, because remember this, any number divided by 0 is undefined. And we cannot plot things that are undefined, okay? So what that means is we must exclude any numbers from the domain that create a 0 in the bottom of a fraction. Now, check this out. For all functions, and this is all functions, So for all functions that do not have a variable in the bottom of a fraction, we know what that means. If I don't have fractions with variables in the bottom, then that means there's no way I can get this undefined stuff happening. So if that's the case, then the domain will be all real numbers. Now, we got to do a few steps. If we do have a fraction, so if my function does contain a fraction, then here's what I need to do. Because I got to look for those numbers that might make that equal 0 in that bottom. So what we do, we set the denominator equal to 0. So y'all, by setting that denominator equal to 0, we're forcing it to find those x values that made that happen. So what we would do after we set our denominator equal to 0, we would solve for the variable. And once I've solved for the variable, I will now have the solutions that made it equal 0. So at that point, we exclude any of these solutions from our domain. Okay, so an example of that, we would have our parentheses, we would have our variable. So the variable is x, such that x is a real number, and x cannot equal whatever numbers we get for our solutions. Okay, so this is our domain. Domain is x can be any real number except whatever made it equal 0 in that fraction, okay? And y'all, that's what the rest of 2.3 is about. We're going to be looking at functions, and we're sort of going to find what their domain might be, okay? So I'm going to start us on those kind of problems. All right, y'all, let me flip this over. So for these examples, and actually the rest of these are all just doing that, they want us to find the domain of the function. Now, y'all, finding domain, we do that pretty much most of this year, okay? So for this problem, they start about number 3 doing this. On this one, I got f of x equals 12 over x plus 7. And also, guess what? When we was talking about the domain of a function, we said the only thing we were worried about were fractions. Well, guess what? I got a fraction here. So it's possible there's a number we could put in for that x that might make this equal 0 down here. Right? So there's a variable down here. So what I'm going to do, since it is a fraction, I'm going to set my denominator equal to 0. So I'm going to set x plus 7 equal to 0. And we're going to solve that for the x. And then whatever solution I get, I got to exclude it from my domain, okay? So y'all, there's only one move to solve that right there. I need to get the x by itself. So I'm moving that 7 over by subtraction. So when I do that, I get my x, that cancels. 0 minus 7 is -7. So guess what? If I put a -7 in for that x, -7 plus 7 is 0. And 12 divided by 0 is undefined. So we're going to exclude -7 from our domain. So our domain will be x such that x is a real number and x cannot equal that -7. And that's the only number I can put in for the x to make that 0. Any other number I can put in for the x, I'll get a number down there. I can divide that by, I can take that 12 and divide by any of those numbers, okay? So the only thing I was concerned about was a -7 on that one. All right, y'all, so I'm gonna play with this now and let y'all sort of answer some of these. So on this one, I got P of X equals 2x minus 10. So I'm looking at this one. And remember, the only thing I was worried about was a fraction. Well, this does not contain a fraction at all. So since there's no fractions on this, my domain is all real numbers. I can put any number in here for x, multiply by 2, and then subtract by 10. There's no way that would ever give me undefined. So for that one, we would have x such that x is a real number. So y'all, I want y'all to really realize that I'm only worried about fractions on this. Oh, here's something. How about this? F of x equals x squared minus 7. All right, y'all. So what's my domain for number 5? What y'all think? Well, y'all, let me ask y'all this. Oh, let me see, these new messages ain't popping up. All right, here I go. Good job, y'all. It's all real numbers. Good job. X such that x is a real number. Yeah, y'all are writing all these numbers and my messages wasn't scrolling, so good job. And y'all, that's basically what you're looking for. Do I have a fraction? Do I not? All right, y'all. So number 6 has g of x equals 8 over 1 minus 2x. Uh-oh, y'all, I do have a fraction again. But remember, we're only worried about our denominator. So you're going to set 1 minus 2x equal to 0. All right, y'all, so here's the thing on this one. We need to get to 2x by itself. Well, to negative 2x by itself. So we'll do that by moving to 1. So it looks like we're going to subtract 1 from both sides. So those cancel, I get my negative 2x equals a negative 1. And then divide everybody by negative 2. So let's see. Now you got, what's that, 1/2? Yeah, perfect, because when you divide both sides by that negative 2, all these negatives make this positive so that you get x equals a 1/2. So good job. So my domain would be x such that x is a real number and x cannot equal a positive 1/2. And y'all, so that's a trick on these. Let's see, I got a couple more of those coming. All right, so I'm gonna move the camera down a little. All right, so number 7 here. P of x equals, oh y'all look at this, absolute value of x minus 2. So I asked y'all, what is my domain? All right, good job. There is no fraction, so that means all real numbers. Good job, y'all. So x such that x is a real number. So y'all, that is basically 2.3, okay? A few graphs you had to look at um, and play with the domain and range stuff, and then finding the domain of these functions, okay? And really the main thing you got to think about in this section are the fractions, okay? All right, y'all. Now 2.4 will take a little bit longer because it's actually getting into doing some actual algebra now. So let me get this camera set. All right, so 2.4 is sort of fun though if you like math. Because y'all, 2.4 deals with the algebra of functions. And guess what? There's 4 operations that I can do on my functions. And we'll give you different terminology for these, okay? So the first would be addition. So f plus g of x. All this means is f of x plus g of x. Now, the only thing I can do when I'm adding two functions, the only thing we can do, y'all, is combine like terms. After dropping the parentheses. Okay, because we always put our functions in parentheses. So when I add them, all I'm going to do is drop the parentheses and then add my like terms. Now, subtraction is really similar to addition, but you got to do one thing on it. So if we had something like f minus g of x, that'll equal our f of x minus our g of x. Now, if y'all remember, in our support, we had to do some distributions of those negatives when we were playing with them problems in support. So these functions are going to be in parentheses. So if they're following subtraction, you're going to have to deliver the subtraction through everything in the parentheses that follow it, okay? So what we would do on this one, we would drop parentheses by distributing the subtraction. So we're going to distribute the subtraction through the second parentheses. Now, after I distributed my subtraction through the second parentheses, there will be no more parentheses left, and then we'll combine like terms. But y'all, here's the thing about this. Whether you're adding or subtracting, when you're adding and subtracting, you do not change the way the variables look. Okay? If you're having x squareds and you subtract so many x squareds, you still have x squareds. Same thing with adding, okay? So we cannot change variables by adding and subtracting. What will actually change the variables is what we got next, multiplication. So this is f times g of x. Well, y'all, f times g of x equals f of x times g of x. So you're multiplying here. So multiplying could be distributing. It could be one variable times another variable. You can have the distributive property. You might even have to FOIL on this. So all forms of multiplication, okay? Now, the one thing you got to remember on this, when multiplying variables, when we're multiplying variables, we add those exponents. So a x2 times a x3, 2 plus 3 will give me an x5, okay? Alrighty, so multiplication could be different things. Distributing, foiling, and others, okay? Now the last operation, f divided by g of x. That'll be my f of x divided by my g of x. But y'all, guess what? What can g of x not equal? It cannot equal 0. Good job, y'all. Okay, so it's a function as long as g of x don't equal 0, okay? And we don't do a lot of dividing in this section, but if you were dividing variables, that's when you would start subtracting those exponents, okay? So y'all, that's what these next few examples are going to deal with: adding, subtracting, multiplying, and dividing. And then I think even at the end, they hit us with a few domain problems, okay? So it all goes back to our domain stuff we were playing with. Alrighty, so this first example, we're given f of x equals x squared plus 1, and g of x is going to equal x minus 2. They want us to find f plus g of x. Hey, y'all, so what I do on these, I take my f plus g of x. So I know we're adding, so I'm going to put my parentheses. I always start out with my parentheses for my functions. So f, which is first, would be the x squared plus 1. G is the x minus 2. All right, so the nice thing about when they're being added, you can drop the parentheses and you don't have to change none of the signs. Okay, so I can drop the parentheses. I get an x squared plus 1 plus the x minus 2. Okay, I don't have to worry about changing signs when it's positive here, only when we're subtracting, okay? Hey, y'all, so at this point, I'm going to add like terms because we said that's all we can do when we're adding is combine like terms. Well, the x squared don't have nothing else, so I'm going to bring down the x squared. Now, y'all, I'm just going to put mine in what we call descending order. So on my x squared, then my x, and then my number. So next I would put this positive x. So y'all look at this. I do have like terms. I got a positive 1 and a negative 2. If you add them together, you get a negative 1. So f plus g of x equals x squared plus x minus 1. Okay, y'all? So that's the trick on it. Keep up with all the operations you're doing. And notice we didn't change any of the variables, okay? So let me see number 2. All right, y'all, this one we're given f of x equals x squared minus 4, g of x equals x minus 2. They want us to find f times g of x. Now, we'll say this. In MathLab, a lot of times they put a dot here for multiplication. But you could have just an f and a g. They could write this like this, fg of x. Remember, two variables next to each other also represent multiplication, okay? All right, so let's see what we got. We got f times g of x is going to equal my f times my g. So I'm just going to put my parentheses right next to each other to represent my multiplication. So the first f will be x squared minus 4. G will be the x minus 2. So y'all, here's the question. How would we multiply this thing? So this is where we would definitely, what you got, Jackson? Foil, definitely. We would foil this. So we would take the x squared and distribute it through the second parentheses. Then we'll get the negative 4 and distribute it through the second parentheses. Both of these have to multiply by both of these, okay? So to FOIL, the first ones from each parenthesis. Well, that's the x squared times the x. Now remember, this x actually has an exponent of a 1 by it. So remember I said when you multiply, you add exponents. So 2 plus 1 gives me a cube. So I get an x to the third. Outermost. The outermost are the two outermost. Well, that's the x squared times the negative 2. That's going to give me a negative 2x squared. So y'all, F is the first ones from each parenthesis. O is the outermost. But if you notice, all we did was distribute our x squared. Now we got to distribute to negative 4. So the negative 4 multiplies by the x, giving us the negative 4x. And y'all, finally, that negative 4 multiplies by the negative 2, because that's the last ones from each parenthesis. So negative 4 and negative 2 will give us a positive 8. And y'all, looks like I have no more like terms, so that'd be our final answer. So now let's see what you got. X3 minus 2x squared minus 4x plus 8. Good job. Oh, y'all, so that's a trick. Remember, at this point, if the exponents don't match, we cannot add those variables together. Hey, y'all, so let me throw you a little curveball here then. So what am I on, number 3 for me? Yeah. So let me throw you a little curveball here. So we're given f of x equals x squared minus 4. G of x equals x minus 3. We want to find g times g of x. So y'all, look what they want. They want g times g of x. So here we go. G times g of x. So I got to put my parentheses now. Well, y'all, the question is, what's going into these two sets of parentheses? What would y'all put in the first parentheses here? So definitely x minus 3. Good job. So knowing that, what would y'all put in the second parentheses? So same thing. So y'all are saying x minus 3. Good job. So notice they're trying to throw you a curveball. They gave you f of x, but y'all, they didn't even ask for f in this. They just wanted g times g. You know, so when you this, I could have wrote this as x plus x minus 3 squared. We'll learn that kind of stuff later. But y'all, we're gonna FOIL this again. So here we go. X times x is x squared. X times negative 3 is a negative 3x. So now we'll distribute the negative 3. So negative 3 times x is negative 3x. And y'all, finally, that negative 3 times that negative 3 is a positive 9. Oh, good job, Nat, because usually what people do when they see this, they cancel those. But y'all, we can't cancel these. They're both negative, okay? So good job. So those are my like terms. So I'll bring down my x squared. And good job, negative 3x's minus 3x's is a negative 6x. And then we bring down our positive 9. Okay, so they doubled in the middle. They don't cancel, okay? So y'all, that's what you got to watch out for them. Are they giving me stuff I need or don't need sometimes? That's what they will do, okay? All right, y'all. So let me see here what I got coming up. Oh, so now they start giving us numbers to play with. So on this one, they say, let f of x. Oh, y'all, hang on. What I'm going to do now, let's take a 10-minute break because we'll be knocking out the whole next hour too. So I'm going to give y'all a 10-minute break real quick. So I'm going to pause our recording. Let's take a 10-minute break and then we'll come back at 11:02 or so and we'll knock out the rest of 2.4. Hey, y'all. So right now we're on 10-minute break. So y'all, I will see y'all at 11:02, okay? Need to do about that little things. Okay. And so everybody back? Let's see, 11:03. So I'm gonna get us started now. So here we go. Hey, also, like I said, this number 4, they're going to give us numbers in this one. So let me show you. So they're giving me, let f of x equal negative 8x plus 11. G of x is going to equal x squared plus 18. But y'all look here. They want us to find f of 7 plus g of 7. Now, we'll say they could have wrote f plus g of 7 since we're putting the same number into each function. So they could have wrote it like that. But they did it like this. So we would come down and say f of 7 plus g of 7 is going to equal our f plus our g. But y'all, guess what? We're not putting negative 8x plus 11 here, because they gave me a number to put in for the x. So what we're going to put in is negative 8 times 7 plus 11. And then over here, we will put in 7 for the x. So this will be 7 squared plus 18. Now, we'll say this. If this was a negative number, I would put it in its own parentheses when I squared it, okay? So basically on this one, order of operations, we got to work inside this parentheses and work inside this parentheses first. So inside the first parentheses, negative 8 times 7 is a negative 56 plus 11. That'll be plus my second parentheses. 7 squared is 7 times 7, so that'd be a 49 plus 18. All right, so I'm down to the last step in each parentheses. So since there's only one operation left, I can drop parentheses once I do my adding. So negative 56 plus 11 is a negative 45. Over here, I got 49 plus 18, which is what, a 67. All right, y'all, now let's see, negative 45 and 67, adding them together. My final step, I get an answer of 22. Oh, y'all look at that on the chat. Both y'all got 22 on that, and so good job. So if they do give you numbers, plug those numbers in for the x's and then evaluate it, okay? Y'all, so the next one's doing the same thing here. So I'm gonna, let's see. I'm gonna skip down and I'm gonna go to number 6, I think. Because 5's pretty much doing the same thing as this one. So y'all, for 6, I'm giving f of x equals negative 20x plus 18. G of x equals x squared plus 10. I'm going to find f of 2 times g of 2. So same thing, here we go. F of 2 times g of 2 will equal my f of 2 times my g of 2. And y'all, once again, I'm putting a 2 in for all my x's. So I'll have negative 20 times 2 plus 18. And here I'll have 2 squared plus 10. So the multiplication would be my last step. I'm going to finish each parenthesis first. Once I get my parentheses done, then we'll multiply, okay? So in the first parentheses, we would multiply first and get a negative 40 plus our 18. Second parentheses, I would square the 2 first and get a 4 plus my 10. All right, also one thing to do in each parentheses. So let's see, I can drop my parentheses after this. So I'm gonna get a negative 22. Actually, I'll probably keep my parentheses since I'm multiplying, right? Then I wouldn't have to put the little dot there. And then what's that? 4 plus 10 is 14. So yeah, since I'm multiplying, I'd probably just keep them to represent multiplication. And then y'all, let's see, negative 22 and 14 is what a negative 308. Let's see, good job, negative 308. All right, this next one, they do a little bit of division on this one, okay? So 7 f of x is going to equal negative 5x plus 9. G of x is going to equal x squared plus 16. So y'all, that they want me to find on this one is f of a negative 4 divided by g of a negative 4. Okay, so like I said, a little division going on. So f of negative 4 divided by g of negative 4. Now I'm going to make mine look like a fraction. So my f is on top, but remember I'm putting a negative 4 in for the x. So on top I'll have negative 5 times negative 4 plus 9 over my g. Now, y'all, I'm putting in a negative number for the x, so I'm going to put that negative 4 in parentheses and then add my 16. Okay, you want that negative number in parentheses if you're doing this on a calculator for sure. Now, also when it's in fraction form like this, we assume that the top and bottom are in their own sets of parentheses, okay? So let's work the top. Multiply first. Negative 5 and negative 4 give me 20 plus 9. On the bottom, negative 4 squared. That's a 16. So the bottom gives me 16 plus 16. Hey, y'all, let's see. Good job. It looks like I'm going to add the top, get 29. 16 plus 16 is 32. And y'all, I don't think that reduces. I think 29 is actually a prime number. So Nat, you done it again, girl, because I get a 29 over 32. Now, y'all, so I'm about to turn my page here so we can get into the next one. All right, so let's see what y'all do on this one like this. This one they're giving me f of x equals x squared minus 3. G of x equals 12 minus x. So y'all, what they want me to find, now y'all watch this one. They want me to find f times g of a little n. So y'all curveball. They didn't give me a number. They gave me an n here. So when we work this one, guess what we're going to replace these x's with? We're going to replace these x's with the n they gave us, okay? So here we go. F times g of n will equal my f times my g. All right, so what is f? X squared minus 3. But y'all, that's not what we're putting here. We're going to put it n squared minus 3. And then for my g, we're not putting 12 minus x. We're putting 12 minus n. Okay, so remember, whatever they put in them parentheses is what we will replace those x's with. All right, y'all look at that. Looks like we're going to do some foiling here because we're multiplying on this one. So I'm going to take the n squared times 12. That's going to give me 12n squared. We'll take that n squared times that negative n. That's going to give us a negative n to the third. Remember, there's an exponent of 1 there, and I'm just adding the exponents. Now distribute the negative 3 times the 12, which is what, a negative 36. And y'all finally, the negative 3 times the negative n is a positive 3n. So it looks like the only thing we got to do is put them in order. So Nat, what you got up there? A negative n to the third, because we would bring that first. 12n squared, good job. Plus my 3n, good job. And then minus my 36. Oh, good job, girl, because that's exactly what I'm getting. I'm putting them in order of these exponents now. So the positive 12n squared, and then plus the 3n, and then minus the 36. So y'all, at the end, all I did was put them in what we call descending order of those exponents, okay? So y'all, that's what you got to watch out for. What are they asking? What operation? And then what am I putting in for them variables if they're giving me something other than an x here, okay? All right, y'all, so watch this. I'm going to skip. The next one was dividing again, like we did a while ago. So I'm going to skip to some of these with the domains in them. So on these examples, it'll say for the pair of functions, determine the domain of the sum. So they want me to find a domain of adding the two functions, the difference. So the domain of subtracting these two functions and the product of the two functions. So this is almost 3 problems in one. I'm going to find the domain of the sum of these two functions. Then I'll find the domain of the difference, and then the domain of the product. And we'll still use that lingo where we said x such that x is a real number and x cannot equal whatever, okay? Now, for this one, they're giving me f of x equals x squared. They're giving us g of x equals 9x minus 9. So y'all, those are my two functions. So let's start out with the sum. The sum, so I'll write sum here. The sum would be f plus g of x. So it's going to be my f plus my g. We know the f is x squared, and the g is a 9x minus 9. So here's the question for the sum. Y'all, what is that domain? Because remember, we just did these in 2.3 a while ago. So y'all let me guess. What do y'all not see here? Oh, key trade. Yeah, let me see what you got. All real numbers? All real numbers, Chase? Perfect. There's no fractions here. So the domain would be x such that x is a real number. Okay, so good job, Jackson. There's no fractions, so it's always going to be real numbers. So then we come and do the difference. Well, the difference will be f minus g of x will equal my f minus my g. So y'all, that's going to be the x squared minus the 9x minus 9. So once again, I'm not going to remove parentheses and work it. I'm just going to go straight to my domain. Because y'all, what's the domain of the difference of these two functions? Oh, what we got? Real, that's it, y'all, real numbers. There's still no fractions here. So since there's no fractions, x such that x is a real number. You'll notice adding and subtracting usually have the same domains. So let's see what this product's going to do. The product would be f times g of x, which will equal my f times my g. So y'all, that's going to be an x squared for f, 9x minus 9 for my g. So the question of the day, what is that domain? And y'all, what we, oh yeah, definitely. It's still going to be all real numbers because you don't have a fraction there. All right, so x such that x is a real number. And you also notice the sum, the difference, and the product, they usually all got the same domains on those, okay? All right, y'all, so hang on just a second. Let me find my next problem. My papers are out of order here. And so that was that. All right, so here we go for the next one. Same instructions. This time, y'all, they're giving us f of x equals 1 over x minus 5. G of x is going to equal 6x to the third. So we'll start with our sum. Our sum will be f plus g of x, which will equal to f plus the g. So y'all, f is 1 over x minus 5. G is 6x to the third. So the question, is this domain going to be all real numbers? So now what you got? X is a real number and x is not equal to 5. Good job. Because y'all, there is a fraction here. So remember, since there's a fraction, we would set x minus 5 equal to 0, and you would solve that for the x. So since that 5 is being subtracted, we would add 5 to both sides. And we get x equals 5. So y'all, for the domain, x such that x is a real number and x cannot equal a positive 5. All right, so let's see, difference. That's going to be f minus g of x, which will equal my f minus my g. So y'all, that's 1 over x minus 5. And g was a 6x to the third. So y'all, guess what? It's the same setup as we had with the sums up here. You've only got the one fraction to worry about. So we're going to still have to exclude that 5 from this fraction. So for that domain, once again, that domain will be the same as the one above, and we'll have x such that x is a real number. And our x cannot equal a positive 5. Yeah, Jackson, you're on there. So same, definitely. So what's next? Our product. So that's going to be f times g of x. See, oh, same thing. I got 1 over x minus 5 times 6x to the third. Well, y'all, guess what? I still only got the one fraction to worry about here. And that x still cannot equal that 5 up there. So for the third time, my domain is going to be the same. It'll be x such that x is a real number and x cannot equal 5. Now, the reason they didn't do some division on these, because if we were dividing by one or the other, we would have to worry about domains and stuff. But what they want y'all to see on these two examples I just did is that the sum, the difference, and the product, they're all going to have the same domain, okay? The ones that would be different would be division. But y'all, they didn't ask us division on those. So let me see. Oh, y'all, so we just got one more to go on here. So let's see what we'll do here. So for F and G, determine the domain of F divided by G. Now y'all, so F of X is going to equal 7x minus 10. G of X is going to equal 10x minus 30. All right, so I'm going to set it up, and then y'all can actually tell me what the domain is, okay? So we're doing f divided by g of x. So my f will be on top, which is a 7x minus 10. That'll be over my g on the bottom, which is a 10x minus 30. So y'all, finally, damn, that you quick up there, ain't you? Oh, that's pretty quick. All right, y'all. So y'all done got it done. So I do got a variable in the bottom of my denominator. So I would set 10x minus 30 equal to 0. Oh, y'all, hang on. I'm trying to pull something up real quick. All right, I'm just trying to pull up Blackboard real quick. Um, I don't think y'all can see this yet. So, okay, there wasn't no support for this. Okay. Okay, so let me go back to solving this. So here I would add my 30. All right, so that brings down my 10x. Those cancel out on that side. That's going to equal positive 30. And then looks like that what you did divide by 10 on both sides. So that cancels, give me a 1x equal to positive 3. So good job. So you would have x such that x is real number and x cannot equal a 3. That's basically 2, 3, and 2, 4. And it's just getting used to this domain stuff, okay? And doing a little bit of that algebra on your functions. So y'all, the main moral of today, when you're looking at the domain, all we are concerned with are definitely fractions, okay? So y'all, what questions do y'all have? Any questions out of anybody? Let's see. I'm trying to look on my chat real quick. Hey, y'all look good then. Um, so if you're not in the support class, Eva, you do not have to do the support homework. Only do the ones that are college algebra. All the support homeworks will be tagged with that support on them. So yeah. So actually today for 2, 3, and 2, 4, there actually wasn't no support assignments for those two sections. I think there is for 9, 1 when we hit that tomorrow though. So everybody should day, all y'all got is your 2, 3, and 2, 4 for college algebra, okay? Alrighty, so let me see if there's more chats here. Yeah, so y'all, I got an appointment I gotta do at today at noon, so I won't be having my support lab today. I know y'all, I told y'all we would actually start it today. But I got like a family situation I gotta deal with. So I won't have a support lab today, but I definitely will tomorrow, okay? Because that's a little bit trickier section tomorrow. So we'll use that to get y'all fixed on everything.